So we're here for 9.4. The main difference in 9.4 is the crazy graphs you probably hated yesterday are out. There's no homemade graphs where they made up ridiculous graphs and made you move them. The bars, the absolute values that made V-shapes are also out. What is in are graphs with squares. So if you have your 9.4 notes paper handy, what this section is titled is something about quadratic functions, I believe. Quadratic functions have an x squared in them. Like in the previous chapter, we had ax squared plus bx plus c, quadratic formula was used, those kind of things. But your notes are describing what I'm reading to you now. Quadratic functions have an x squared. The graphs of x squared graphs are U-shapes, and the technical math name of those is parabolas. The bottom, or the top if you had it flipped, is called the vertex. We've been using that word the last couple days. What we haven't used is a word, a phrase called a line of symmetry. There's always a line that cuts our U's in half. A lot of times that's been the y-axis. That line is called a line of symmetry, and that's going to be a word featured in the homework for the first time tonight. So first, before we get graphing anything or talking about graphs, we'll again graph the basic graph. I did this a couple days ago, but it hasn't been in the homework for a little bit, so we'll get back after that now. So if I decide to graph the basic graph, y equals x squared, you start at the origin. Over 1 up 1 is both of our main graphs, the absolute values and the squaring. But over 2 goes up 4 when we do squaring, and that's our basic graph. Today, what they're going to ask you to do is list for them the coordinates of the vertex. And for this one, that's pretty easy. It's at the origin. A lot of our graphs have had vertexes at the origin. The second thing they're going to ask you to do is describe the line of symmetry. The line of symmetry for this one would be the y-axis. The y-axis is the line that cuts this in half. The technical name of the y-axis is the line x equals 0. You might or might not remember earlier in the year, any x equals lines went this way. That was around the time that we learned that vertical lines had no slope. We learned that y equals lines went that way. That was around the time that we learned about zero slopes and positive slopes and negative slopes. It was in that family of information. But x equals lines always go this way. Every line of symmetry will have to be an x equals line. For a lot of the U's, the line of symmetry will be the line x equals 0. However, if the graph gets moved to the right, those items move. If the graph got moved to the left, those items would move. If we move those up, only the vertex would move. The line of symmetry is still the y-axis. Likewise for moving down. Stretching would do nothing to any of that. I could go wider, I could go taller. Wider, taller doesn't affect those items. But we are going to have a change when we move right or left today in this homework. The vertex and line of symmetry will be in new locations. So what we're going to do first for all these problems, and what's probably the most important skill, is to be able to write the descriptions for what's supposed to be happening. In the homework, I think they write the problems this way. If you want to write them this way, these two things, those two symbols mean the same thing. Y equals whatever, f of x equals whatever. It's just two different things that mean the same thing. It looks different, but it isn't. So whichever way it's written, don't worry about that. What we are looking at is what these numbers are doing. So if you want to self-test yourself, what you could do with this, and what you could do with these that are, I believe, on the back of the page of notes, you could give yourself a quick self-test. Do you know 3 times taller, half as wide, right 1, up 2, flip it upside down? Can you do that stuff? Give yourself a self-test with those and we'll see. Not all of the variations are used in this homework. Those will build back in future days as we proceed through chapter 9. So on the board, the changes on the board are reflecting the kind of changes that will be in the homework. If it's not in the homework, I just skipped it up here. But if you want to pause, go ahead. When we come back, what we need to know is that the negative flips things upside down. We need to know that the 3 makes us 3 times taller. And we need to go left 1. When I step over here, this is just a 3 times taller, so that's a more basic problem. Look, I'm going to slide a little bit farther here. This would just be 3 times taller. This would just be flipped upside down. This is upside down and 4 times taller. This is left 3. This is 2 times taller. And this is right 4. Those are the variations you'll see in the homework. You will see some rights, you will see some lefts, you will see some talls. You will not see any wides. If there were wides, the numbers would have to multiply and be inside the parentheses. There's none of that. You will get some upside down flipping, you will not get any right-left flipping. If it were right-left flipping, you'd have to see negatives multiplying in the parentheses, and you'll never see that today. You will not see ups or downs. If I wanted to go up or down, I'd have to add or subtract, like at the ends of these. If I threw on at the end of this a +6, it'd go up 6. If I threw here outside the parentheses a -4, I'd go down 4. But none of that's going to happen. The variations you have today are tallness, upside downness, lefts and rights. Back to the left a smidge. So if we go to graph this one, this is the hardest one to graph, so I'll just graph this one and we'll see how we're doing on time when we get over there. This one, we always do the left-right moves first because that spots the vertex. So we go left 1. Then if we're flipped upside down and 3 times as tall, we'd want to go over 1, but down 3 instead of the usual 1s. And then usually 4 is the most of anything we do. Instead of 4s, if we're 3 times as tall, we're 12s. So over 2 from the vertex, vertex is our home base now, over 2 all the way down 12, both on the right and on the left. And we would get a flip, super tall U, and it got nudged left a square. To list out the vertex, we didn't need to graph it. It probably helped us the first time to do it. Okay, but to do the graph out, we can locate the vertexes right there at -1, 0. Since all of the moving today is left or right, nothing's moving up or down, the vertex's second number will always be 0, and the first number would just be decided by the left-rightness of it. The line of symmetry will always be an x equals line, because they are running this way. We had that discussion a minute ago. The line of symmetry, you don't have to draw it on there. I'm drawing it for you. You don't need to draw that on anything you graph. The line of symmetry is the line x equals -1. -1 should not be a shocking number because we just had it. These numbers will always be a match for each other for now. And they'll be based on the fact we moved left 1 to create both of those numbers. So if I want to complete this information to the right, if my only change is to go 3 times taller, the vertex is still at the origin. If my only change is to flip upside down, the vertex is still at the origin. If I do both of them, the vertex is still at the origin. A lot of our vertexes, or vertices, that's a weird word where you can pluralize it in 2 ways, are at the origin. But if you move left or right, the vertex has to move. Left 3 would be sitting at -3. Second number today will always be 0 because they took it easy on you. There's no up-down motion. If there were up-down motion in a future day, which there will be, then the second number would be something else, but not today. If we go right 4, we go 4, 0, and that's how we do the vertex. So the key thing, in my opinion, is the ability to write the description. We've been working on that for a few days now. If you can write the description, the vertex is going to be a right-left number, comma 0, every time. The line of symmetry, blindly, you can by faith just commit to x equals, not just today, but every day for this whole chapter. The line of symmetry are x equals lines that go vertically. And you just need to grab the x number that you used, because the line of symmetry is an x fact, so the vertex uses the x numbers. So 0, 0, 0, -3, +4, we just use those. Those are the numbers that we're using for that. I'll do some graphs, because the homework will make you a graph as well. So, let's do this one first. That's the easiest one. So if I want to graph this, I just have to go upside down. So origin over 1, down 1, over 2, down 4. That's just our normal basic shape, and we want to mirror left and right, and that would do just fine. We do this one next. That's probably another easier one. If I want to just go left 3, go left 3 for the vertex, and then replicate our normal shape that I've tried to convince you to just memorize. The motion of this is over 1, up 1, over 2, up 4, and to let the left exactly mirror the right to create yourself a U shape. If I want to do this one that's 3 times taller, that can fit in here. I'm only going to go over my 2's, but I drew it so I have space to go nice and tall, because I'm not going to end up going only 4. 3 times taller, 7, 8, 9, 10. Well, I need to be ready to rise as high as 12. So origin over 1, 3 times as tall, and over 2 maxes out all the way to the 12 I had pre-counted there. Shape. If I go to do this, the -4x squared, we're flipped upside down. So I could do myself something like that that's going super far underground. We're gonna go over the 2's like we usually do. But the underground here, not the normal 4, but 16. Okay, so over 1 is down 4, still using that origin. And when we go over 2, that's super far flipped and 4 times as tall. We're going way, way on a long trip. Then this last one would be more normal size. We go right 4, and then it's going to be twice as tall. For available space, this isn't bad, I guess. Clear that little smidge away. So we're going to go right 4, and then 2 times as tall would have a maximum pop, not at 4, but at 8. So from the vertex, go over 1 and up twice as tall as usual, which is 2. Over 2, and we're going all the way to the top to my 8. And then the left, as always, matches the right. Everything counting from the vertex now. We don't care about the origin at all anymore. Homework based on this is on page 400, which goes from 1 to 18. So we'll just keep at the pace the way we would if we were in school. So whatever you're watching this video, whatever day you're watching this video, the lesson tomorrow would be me just answering questions. So for that to happen, you'd have to send me questions. So if there are questions, tomorrow is me just answering questions, whether that's by email, whether that's by making another video, whether that's however it is. I'll answer questions I get. That's what tomorrow's project is, and just catch up on these pages in chapter 9. You have in your packet a sheet as well. That sheet would be then 2 classes away from today's class. Today's world is watch this, do 400 for tomorrow. Tomorrow would be just catching up, and then the next day would be a sheet that would be tried to be completed, and you'll worry about that soon enough. Again, email me questions. Let me know if you need anything. Hope this is working for you.